glucose, it's often measured with a finger prick. Maybe you already did that also for a course here. But this 2-hour plasma glucose is, now you can of course do this after someone just had breakfast or had a drink or anything else, but to standardize this a bit, we often use an oral glucose tolerance test. So in this case, people get something to drink, so a solution with a known amount of glucose, and then we know, or we can estimate how much their glucose level should rise 2 hours after the test. So this is a different way of measuring the glucose levels. Then we have the HbA1c. This is usually not done by a finger prick, but really by taking a blood sample. And some newer forms of measuring glucose is by these kind of sensors that you can put on your arm. And these sensors measure the glucose levels multiple times, so most of the time every 15 minutes. So you get a, well, not one time point, but multiple time points over a day. And here you can also calculate something like time in range, which refers to the time, like the part of the day that you're in between a certain range of your glucose levels. So you can say, well, okay, levels should be above 4 and below 11, and then you can calculate how long of a day people are within these ranges. You see quite new measure. You would also read in some papers that when they're often using these kind of measurements, they, besides writing about fasting glucose levels, they also tell you something about this time in range. Measuring insulin sensitivity is more complex, I would say. For this, I also refer to this book chapter. Well, I hope it's on Brightspace. And we also need this, I think, for the assignment of Thursday. So I would recommend you to take a look at this later this week. And don't forget to check the reading instructions, because you don't have to read everything. But I will just go quickly over the ways of measuring insulin sensitivity. And then the rest you can read in this book chapter as well. So if we want to measure insulin sensitivity, well, we can of course measure something here. We can measure how much insulin our pancreas produces. But actually we want to know, if we're referring to insulin sensitivity, how much glucose our cells can take up. Because this really reflects the uptake of glucose, so the response to insulin. And there are different ways of doing this. So if we talk about how much insulin is produced, we have, for example, measures about fasting insulin or C-peptide, or something called OMA-IR. And if we talk about how sensitive our body is to insulin, so how well our body responds to insulin and how well our body can take on glucose, we have different measurements, so M values and insulin sensitivity indexes. And especially these two, we will also use during the assignment on Thursday. But to tell more about the other two, well, fasting insulin, as I said, insulin is just circulating in your body, and you can measure the levels of insulin when people are fasted, same as we do with glucose levels. And then C-peptide is something different. You can also measure this in your bloodstream, and it's actually related to insulin, because when insulin is produced by your pancreas, it's not produced in their active form, but in an inactive form called proinsulin. And only when it's cut here, the insulin is released. And the part that is not used, or that is not working as insulin, is called C-peptide. And this is when we measure C-peptide, we can know how much insulin is produced, because you can cut the proinsulin into two types, one type insulin, one type C-peptide. So it tells us something about how much insulin was produced and how much is still circulating in our body. So we often use this to compare the C-peptide and the insulin levels to see, well, how much of the insulin is used and how much was produced in the beginning. Then I thought about the OMA-IR. This is a formula to compare the fasting glucose with the fasting insulin levels. And here it's just a calculation. And we say that a level higher than 2 indicates insulin resistance. So the lower this value is, the better your body can respond to insulin. Also, this formula we will use in the assignment on Thursday, but you can find it also in the book chapter as And good to know is that there are more formulas like this, just ratios between fasting glucose and fasting insulin. But the OMA-IR is, I would say, the most often used. Well, then we have if we want to measure how much glucose is taken up by our cells, we should take a different approach. So for this, we refer to the M value, or the glucose disposal rate, which tells us something about how fast our body can dispose glucose, or how fast the glucose can be stored somewhere. And this is often measured during a euglycemic hyperinsulinemic clamp, which is a very complicated procedure, I would say, but it's used as a golden standard for measuring insulin sensitivity. So all the others I mentioned, such as the fasting insulin levels or the C-peptide, are just kind of proxies for how much insulin, the function of insulin. If you really want to know how well our body can take up glucose, you should perform this clamp procedure. And I don't think the sound is working, so maybe I will just skip this video and explain it to you like this. In this clamp method, people will come to the research facility after an overnight fast, meaning that their glucose levels are very low, and then you supply glucose and insulin, and you just measure what's happening in the body of people. The insulin is given at very high levels, and that's what's referred to the hyperinsulinemic in this name, which means that the level that your body is producing, the level of insulin that your body is producing, is way lower than the levels that you're giving to someone. And by this, you only measure how well your body responds to insulin, no matter how well your body is able to produce insulin. And then you measure glucose levels at different time points, and very frequent. And in the end, something is happening like this. You reach a steady state of your glucose level, so your glucose levels stay somewhat stable, like this here. And this is referring to the word clamp, because we say that the glucose levels are clamped now. In the book chapter I also shared with you, they explain this procedure in more detail, and I think it's also good to go over this again on Thursday. But just for now, the level you get out of this, or the factor you get out of it, is an M value, and this reflects the level of glucose that is disposed in your body. And then we say, well, if this value is low, your body is insulin resistant. If this value is high, your body can easily store the glucose, and this means that your body can respond well to insulin. And to illustrate this, I show this picture from a study where they compared people who were healthy and who had metabolic syndrome. And here you see in black the healthy controls with a higher M value, and people with the metabolic syndrome with a lower M value. You see here that they use the same method, because it's actually the only way of getting this M value is by performing this clamp method. Well, as I said, more information on this method and also on the calculations can be found in the paper, but we will also go over this on Thursday. And I think now is a nice time to have a break. So, shall we start in 5 minutes?
For about 5-7 minutes. Just as a reminder, I just noticed that all of Iris's slides are numbered. If you are making notes, maybe it would be easy to refer to what slide number you want to associate those notes with, just because I know we don't have slides already available, just as a suggestion. So we can meet in about 5 minutes.
Zit die op? Zo gewoon het in het midden laten, dan moet je ook weer zelf even je keuze maken. Als je het echt weet.
You can 5 minutes to start again. I think we are still missing 1 or 2 people that I looked at. So the second part of this lecture, I will tell you more about risk factors of type 2 diabetes, and also about different treatment options. And I would like to show you this picture in which you see the a timeline in years. And here this is the time, the onset of diabetes, and where, well, actually the point where people are diagnosed with having diabetes. But what you can see is that already before this, 10 to 15 years before, things are happening in their bodies that relate or that actually lead to the development of type 2 diabetes. So in the bar above, you see the glucose levels, and you see already that levels are a bit elevated. So this is the post-meal glucose, and this is the fasting glucose levels. And then when people are diagnosed with diabetes, then the levels go up even further. And here you see the levels for insulin, and in red this is the insulin response. So that means the how much insulin is produced actually. And in orange you see the level of insulin resistance. And what you see is that this orange line is already at this high point when people are diagnosed with diabetes. So they are actually at a insulin resistant stage. But that the red line starts to go down, meaning that even or also in people with type 2 diabetes, the beta cells are not able to produce sufficient levels of insulin anymore, causing the glucose levels to go up even further. But if we talk about risk factors, we should actually take a look at this stage before people are being diagnosed and what's actually happening when they have pre-diabetes or even before the period of time. So there are different risk factors for type 2 diabetes, and I will just highlight some of them throughout the rest of this lecture. So there's family history of diabetes, which refers to a genetic component of the disease, but also things like overweight, dyslipidemia, hypertension, increased or impaired glucose tolerance, so high glucose levels, but not yet at the levels of having diabetes. And also things more related to lifestyle. You can think of nutrition, but also physical activity or bad sleep or stress. You also see here the history of gestational diabetes. We know that women who had or who developed diabetes during pregnancy, they sometimes, their diabetes goes away when they labor, but we also know that they have a high risk of developing diabetes type 2 later on in life. And also age is a very important risk factor for diabetes type 2, which is also shown in this figure. You see different age groups and the prevalence of diabetes type 2 among these different age groups. And you see that, well, the older people are, the higher the prevalence of diabetes. They also made a distinction between men and women here. So in yellow you see the men, and in red you see the women. And you see that actually for most age categories the prevalence is higher for men compared to women. Women is actually not very old. It's actually also because I'm also doing research with people with type 2 diabetes, and well, we just distributed flyers among citizens of Wageningen, for example, to participate in our studies. But we clearly see that there are way more men joining our studies than women, because it's just more prevalent among men than among women. Family history is another important risk factor. I said there's a genetic component in the disease, so it's not only lifestyle or only age that is doing something, it's also your genetic risk profile. And what you see here is a study in which they compared people who have diabetes with their parents. So they checked if people who had two parents with type 2 diabetes were at higher risk of getting diabetes themselves compared to people who had no parents with diabetes, or only one, or if the father or the mother would be lead to a higher contribution of the risk. And what is shown here is that people who had any parents, so either the father or the mother with diabetes, they have an increased risk of getting diabetes type 2. When you have both parents, the risk is almost, is doubled, showing that there is a clear inheritance here. And of course, by these studies, this is the crude model. you would say, yeah, well, maybe it's also what people eat in their homes, where there's a strong nurture compound as well. But even if they correct for these factors, you still see that there's a high risk in the people who have two parents compared to people who have no parents with diabetes. We do not really know, actually. Yes.
If there is type 1 diabetes in the family, is there also like a bigger chance to get, for example, gestational diabetes?
No, that's not. We don't see that. We do see some genetic factor in type 1 diabetes. So we know that people who have type 1 diabetes, there's some genetic factor in there, but it doesn't really translate to gestational diabetes or type 2 diabetes. We do know that people, because type 2 diabetes and gestational diabetes are somewhat similar, so there we see that people, or the women who are pregnant and develop diabetes, they might also have a higher risk of getting children who have type 2 diabetes or gestational diabetes. But for the different types, like type 1 and type 2, it's not, there's no similarity in there.
So I have a brother who has type 1 and a sister who has gestational diabetes. So is that like pure
Coincidence?
Pure coincidence?
Yeah, well, I don't know. I mean, I'm not a genetic expert, but based on the research we have, yeah. Of course, there could be something related there. It's not something that's common in research. No. But the thing is that we do not really know how this genetics actually influence the risk of diabetes. So we know there is some genetic susceptibility for specific people for both type 1 and type 2 diabetes, also for gestational diabetes, but we do not really know why or what gene specific or how this transfers to different generations. So what we know is that there are multiple genes that play a role in here, and they're mostly related to the beta cell function, so to the function of your pancreas, but we do not really know how this, what mutation is causing what, or how these defects are inherited. Another important factor is lifestyle, of course. There's actually an interesting study among Pima Indians, which is a group of people with a very high incidence of, or very high prevalence of diabetes. You see here that, well, 1/3 of the men has type 2 diabetes, and even 40% of the women has type 2 diabetes. And because they're, well, they're all from the same group, so they're all from the Pima Indian group inherited. We always thought that this was also due to their genes, that they were somehow very susceptible to getting type 2 diabetes. But a couple of years ago, a group of researchers investigated the role of lifestyle in this group. And what they saw was that people that moved to the US, so these are the people from the same, from the Pima Indians that moved to the US, had a way higher incidence of getting type 2 diabetes compared to the people who belonged to the same group but then stayed in Mexico, because that's where they originated. And this actually showed that apparently there's something different in Mexico and the US that made these people having a very high chance of getting diabetes. Well, and the researchers concluded that this is something in the environment, and perhaps it's something related to lifestyle. And of course, it could still be that these people, like the interaction between their environment and their genes, make them very susceptible for getting type 2 diabetes. But I think it's a clear, clear study showing that the lifestyle plays a very important role here in the development of type 2 diabetes. And this also relates to being overweight. You also saw in the picture here that the people, most people, do have overweight here. So the lifestyle closely relates to that, but it also relates to dyslipidemia, so something happening with the lipid levels of in the blood. And these two are closely related because if people are overweight, there's often a high level of fat that is not only stored in their adipose tissue, but also in other organs or other places in your body. And we refer to this as ectopic fat, which actually means fat that is not stored in your adipose tissue, but at different places. So for example, you may have fat storage in the area of the heart, but also you see here the kidneys, or even here. And what you see on the right side here is that these two, so the fat that is more stored in your arteries or in your heart area or your kidneys, increases the risk of vascular diseases. But when fat is stored in muscles or in the liver, or visceral fat, mostly relates to metabolic risk factors. So these are also very important for the development of type 2 diabetes. And lately, a lot of research has been done on if we can also differentiate people within the group of people with type 2 diabetes to different groups of organ-specific insulin resistance, because we know that the more fat is stored in an organ, the less the organ is able to respond to insulin. So apparently there are people who have these insulin resistance in their whole body. So here we could not really differentiate between any organs that played a major role. But there are also people who have mostly fat storage in their muscles, and the liver is doing perfectly fine, but it's just that their muscles do not respond to insulin. And there's also groups that do have the other way around. So there's a lot of their muscles are perfectly fine to respond to insulin, but we see a lot of fat stored in their liver, and the liver is not reacting to the hormone. And the reason why is actually quite complex, because there's a lot of processes going on when your body is storing fat, when you have excessive calorie intake, and your body needs to store the fat somewhere. So on the one hand, you have macrophage activation, so there's some form of inflammation happening. On the other hand, there are also other processes going on related to the liver or the muscle or your pancreas. And what we see is that when when your body starts to store fat somewhere else, so not really in your adipose tissue, but in other places in your body, the fat tissue starts to release free fatty acids. And this you can also measure in the bloodstream, so there's a lot of free fatty acids circulating inside your body. And we think that this is causing different organs to respond in a different way. So for example, we know that when there are a lot of free fatty acids circulating, that the liver starts to store them, and that you get non-alcoholic fatty liver disease, because the free fatty acids are just stored in your liver. We also know that these free fatty acids cause your muscles to respond less to insulin, so we see a lower uptake of glucose in your muscles. And we also see that the beta cells start to die actually, and that your insulin secretion goes down. And there are also things happening with your heart, so there's a reduction in your cardiac function, and your process of atherosclerosis starts going on. So there's this whole, cascade, I would say again, with processes going on when your body has too high levels of adipose tissue. And to show also the relation between insulin sensitivity and the amount of fat that is stored in your muscle, I show you this picture with the M value here. So this is the value that you get from the clamp method. And as we said, the lower this value is, the worse your body is able to produce to respond to insulin. So you want this level to be high, and you see this is only high when the amount of fat in your muscle is low. You see the more fat is stored in your muscle, the lower the M value will be. But then apparently this is not always a bad thing, because in this study they compared people with type 2 diabetes with endurance athletes, and apparently also endurance athletes have a high level of lipid droplets, so a lot of fat accumulation in their muscle cells or in their muscles. So although we know that this is the case, that there's clearly a relation between the amount of fat in your muscle and the sensitivity, the insulin sensitivity, apparently there's something going on here in these athletes that, well, they're perfectly healthy, but the fat is doing something there in their muscles. Yeah.
And in the athletes, the insulin sensitivity was also lower?
No,
Okay.
they are perfectly fine in responding to insulin. Yeah. So what they think is that, well, it's explained here in lipid droplets, but that it's the location of the where the lipid droplets are stored in the muscle that makes in type 2 diabetes that the muscle is not able to respond to insulin, whereas in endurance athletes they can use actually the lipid droplets as a fuel. But the difficult thing here is that you need very sensitive methods to measure where the fat is stored in your muscle cells. For example, in the study that we are running currently, we are making an ultrasound of the upper leg, so we can see how much muscle or how much lipid is inside the muscle, but we don't really know where specific it is located. So it's very difficult to say where the lipid droplets are located in the muscle cells. This is actually a similar figure, but then for the fat content in the liver. So you also see here that the higher the fat content in the liver, the lower the insulin sensitivity index. So the lower, the less sensitive you are to insulin. And this also shows that it's not only the pancreas or not only the liver that has to do with this relation between insulin and glucose in terms of type 2 diabetes, but that there are more organs involved, and it's actually quite a complex process that is going on. So in the figure with the fat cells, we saw that there's an increased release of free fatty acids, and this is causing there's a reduction in the uptake of glucose in the muscle and a reduction in glucose disposal. And that is more related to the adipose tissue and to the muscle cells. But then we also have the pancreas that plays an important role. For example, you can imagine that when the levels of glucose stay high in your body, that there's also less glucagon produced, for example. And then it also causes a higher output of glucose by the liver, for example. So there are all different organs playing a role here. And in the end, we think, and that's also what we see when the body of people with type 2 diabetes is not able to produce sufficient level of insulin anymore. And it is because your pancreas gets exhausted. Because it's, well, the glucose levels stay high and the pancreas starts to produce insulin more and more and more to counteract this effect. But in the end, it cannot hold up, so it just gets tired with it. And the beta cells start to die actually because they are exhausted. I just showed you this picture to know that it's not only the relation like what's happening in your blood or in your pancreas, but it's an interplay between all different organs in your body that play a role in the process of insulin resistance and insulin sensitivity. And then the last part of this lecture, I would like to focus a bit on the treatment options. We will also talk about this more tomorrow because diet plays a very important role in the treatment of people with diabetes, both type 1 and type 2. But to take it from a perspective of the doctor, I would say we make a distinction between type 2 and type 1 diabetes, and in type 1, there's actually only one problem because the body of people with type 1 diabetes do respond to insulin, but it's just a problem that the beta cells do not produce insulin. So when you give people injections with insulin, they are usually able to control their glucose levels. In type 2 diabetes, we focus on multiple things. So on one hand, we need to improve the insulin sensitivity. We also need to lower the glucose levels because they stay high for a long period of time. And because the pancreas, as I just said, is after a while not able to produce sufficient levels of insulin anymore, sometimes also the injections of insulin is needed. So when we look to the treatment of type 2 diabetes, doctors often use this step-by-step scheme. And you see in the first option is to give people nutrition therapy and an activity plan, which mainly focuses on a healthy diet and sufficient physical activity. But if that does not work, so if the glucose levels still stay high, doctors start often with the oral monotherapy. So this is just one pill, so to say. And if that doesn't work, there are also different combinations of medications that someone can give. And then only, in the last phase, people will get insulin. And what I often see in people who also want to participate in my studies is that they really do not want to start with their insulin. And it can be a very motivation to prevent, because many people use oral drugs, but it's really a motivation that they don't want to start using insulin, because that has a major impact on your life if you have to inject yourself with insulin multiple times a day. I'll tell you a bit more about these oral therapies. There are different classes of drugs and different medications that are used. I wrote down here oral therapy, but since this year there are also some injections that are given, which are the GLP-1 agonists. And by this, people lose a lot of weight. And maybe you've heard about this in the news, but it's a diabetes medication that makes you lose a lot of weight in a very short period of time. But there are also other drugs, such as the metformin. This is, it increases the presence of blood. So you show in the picture before that this is a transporter that moves through the cell membrane to absorb the glucose. You can imagine that if you have more of these transporters, that it's also easier to take up more glucose inside your cells, and that your glucose levels go down. SGLT2, they make the kidneys excrete more glucose. So this is actually, not funny, but in the beginning I told you that the way of diagnosing diabetes a couple of years ago, or many years ago, was because people had very high levels of glucose inside their urine. But what these medications do is actually they make sure that your body gets rid of the glucose by peeing it out. So people who use this kind of drugs indeed have very high levels of glucose in the urine. And then we have two other drugs to increase the insulin secretion. So here, if the pancreas is still able to produce insulin, these two drugs can be used to stimulate the insulin secretion. Also, the treatment of other risk factors are very important. This is a study in which they show how many overlap there is in risk factors between people with diabetes. So you see that 100% has hyperglycemia, which makes sense, of course, but also a lot of people have obesity or dyslipidemia or hypertension. And this may all lead to CVD, but it's very important to also treat these diseases to prevent people from getting cardiovascular. And this is actually where the potential for dietary interventions come across, because I think diet is one of the ways in which we can not only target the high glucose levels, but also the other risk factors for getting cardiovascular diseases. But I will tell you more about that tomorrow during a lecture on dietary interventions. And as you can also see in the schedule, on Thursday we have the assignment in which we go over the measurements of insulin sensitivity again. And that was my talk for today, so I'm not sure if you have any questions so far. Thank you then, and I'll see you tomorrow.
If you have a few minutes, because we are done ahead of time, if you have a few minutes and you'd like to speak to Iris one-on-one, you're very welcome to do that as well.
Of course. Yeah.
Yeah. Continue tomorrow.
Yeah, I think.